For a confidence level of 94%, find the critical value. So we have a level of confidence of 0.94, and what we want to do is find a critical value that corresponds to that. So the critical value, based on that given level of confidence on a normal distribution, there's a formula for this. We do the absolute value of the inverse norm, or whatever technology you're using to come up with inverse norm probabilities is fine, but the input is 1 minus your level of confidence divided by 2, and that's how you get your answer. But to show you why that works, let me show you an app very quickly. So the goal here is to find, balance this green area that I have here about the mean. So this lower z-score, z1, needs to be the same distance away from the mean as this upper z-score, z2. So their z-scores need to be equal. So if I have the upper z-score at 1.62, to have things balanced, I need the lower z-score to be at negative 1.62. And that area in between, I'm trying to reach 94%. So right now it's slightly less than 90, so I'd need to go a little bit further and try and determine what value is closest to 94%. Now, that's going to take some time to really get that to land exactly where I need it to. So instead, I'm going to try and take advantage of technology to help out. Effectively, what I'm going to do is I'm going to take this green area and I'm going to do the complement of it. And when you do the complement, you'll end up with this area in the tails. So if the area between these two values is 0.9312, then the area on the outside is the complement of that, which hasn't updated, but it would be like 0688. So that is why in your formula you have the complement. Now, the thing is, this distribution is perfectly symmetric. So there's as much area in this upper part as there is in this lower part. So it's exactly half, in fact. So if I take that 0.0688 and divide by 2, then that gives me 0.0344 on each side. That 0.0344, that is the area to the left, or the area to the right as well. Notice I get the same value on each side. So it doesn't update the area, unfortunately, but it's 0.0688 for both, and then half in each. Now let's go back to this formula. Notice the formula says to take 1 minus the level of confidence. So when I take 1 minus the level of confidence, I am looking for the area in the tails of the distribution, and then I'm dividing by 2, which gives me the lower tail. That's why the formula is written the way it is. So to find this, I'm going to do inverse norm of 1 minus 0.94 divided by 2, and then take the absolute value in the end. All right, so if I come up with my calculator and just start off 1 minus 0.94 divided by 2. So I'm looking for 0.03 in the lower tail. All right, now, since inverse norm can do the lower tail distribution, so if you hit second and vars and come down to inverse norm, just put your lower tail distribution area in. If you're using the stat wizards, then mean and standard deviation, because we're on a standard normal, just leave those as 0 and 1. If you're not using the stat wizards, just type inverse norm of 0.03, because you can leave these last two inputs blank if you want, and that's fine. Now it comes up with negative 1.88, and critical values are generally considered the positive answer of that. So the positive answer would be positive 1.88. And just to verify that that works, let's switch back over to the app, and I will go back to between, set the lower z-score as negative 1.88, and the positive z-score is positive 1.88, and find the area between those, and that's about as close as we can get to 0.94 as expected. And since the critical value is the same distance away from the mean on each side, we just use the positive one because you know that it would be either the positive or negative of that same value.